In the vast emptiness of interstellar space, a relic from humanity's golden age of exploration has stirred. Voyager 2, launched in 1977, has been drifting through the cosmic void for over 4 decades, its instruments growing silent as its power dwindled. Designed to explore the outer planets and eventually sail into the unknown, it was expected to fade into obscurity, a silent testament to human ingenuity. But in 2025, something extraordinary happened. Voyager 2, long thought to be on the brink of death, sent a signal that defied explanation. A transmission that was not just data but a warning. This is the story of that signal, its implications, and the profound questions it raises about the nature of reality itself. Voyager 2 was never meant to last this long. Launched by NASA as part of the Voyager program, it was designed to study Jupiter, Saturn, Uranus, and Neptune before continuing its journey into interstellar space. Powered by a radioisotope thermoelectric generator, RTG, its systems were expected to gradually shut down as the plutonium decayed, leaving it a mute wanderer by the early 21st century. By 2020, many of its instruments had already been powered down to conserve energy, and communication with Earth was limited to faint whispers via its high-gain antenna. Yet, in early 2025, engineers at NASA's Jet Propulsion Laboratory, JPL, noticed something peculiar. Several of Voyager 2's long-deactivated instruments, sensors untouched for over 30 years, suddenly came back online. No commands had been sent from Earth. No firmware updates had been issued. The Cosmic Ray Subsystem, CRS, the Low-Energy Charged Particle, LECP, instrument, and even parts of the Plasma Wave Subsystem, PWS, were reporting data as if they had never been shut off. At first, the anomaly was dismissed as a glitch, possibly caused by cosmic radiation or a fault in the aging onboard computer. But then came the event that changed everything. Voyager 2's high-gain antenna, its only means of communicating with Earth, shifted its alignment. This was no minor adjustment. The antenna, which had been precisely oriented toward Earth for decades, reoriented itself with surgical precision to point toward an empty patch of space in the direction of the constellation Telescopium. No known stars, planets, or objects of interest lay in that direction. The maneuver was uncommanded, defying the spacecraft's programming and the laws of probability. What followed was a transmission unlike any Voyager 2 had ever sent. The signal was dense, compressed, and highly organized, displaying properties that ruled out random noise or cosmic interference. Engineers at JPL, accustomed to parsing faint telemetry data, were stunned. The signal's entropy level, the measure of randomness in a data stream, was far too low to be attributed to natural phenomena like cosmic rays or stellar radiation. This was no ordinary burst of static. It was structured, deliberate, and eerily purposeful. Initial attempts to decode the signal using standard methods failed. The data didn't conform to any known telemetry protocols. Desperate for answers, the team turned to artificial intelligence. Using advanced neural networks trained to, the AI uncovered something extraordinary. Repeating patterns within the signal that resembled the architecture of neural networks. The data was self-correcting, recursive, and bore a striking resemblance to machine learning algorithms. This wasn't a telemetry report. It was a message. As analysts dug deeper, they discovered mathematical harmonics embedded in the signal, ratios mirroring the Fibonacci sequence and the golden ratio, patterns found in natural systems like spiral galaxies and seashells. These findings suggested intent, a hallmark of intelligent communication. Renowned physicist James Benford, a SETI researcher, noted that such tightly compressed, self-correcting data would be an ideal method for an advanced civilization to communicate across vast distances. It would conserve energy, resist distortion, and remain intact over billions of miles. The question was no longer whether the signal was intentional. It was who or what had sent it. The discovery prompted scientists to consider a radical hypothesis. Voyager may 2nd have encountered an informational field embedded in spacetime. Theoretical physicists have long speculated that space is not merely a vacuum but a dynamic medium capable of storing and transmitting information, much like a cosmic operating system. In this model, plasma waves, magnetic fields, or quantum fluctuations could act as carriers for data, similar to neurons in a brain. If Voyager 2 had passed through such a field, it might have triggered or detected a message encoded within the fabric of the universe itself. This idea, once confined to the fringes of theoretical physics, gained traction as the signal's properties defied conventional explanations. The presence of the Delta 13 sequence, a set of low-frequency pulses repeating 27 times over 31 days, added to the mystery. The pulses were too precise to be random, too consistent to be accidental. Their purpose remained unknown, but their existence suggested that Voyager 2 was interacting with something far beyond its design. The most unsettling hypothesis emerged from quantum cosmology and string theory. Voyager may have crossed into a transition zone, a region where the fundamental rules of physics, time, and causality behave differently. Such zones, theorized to exist at the edges of black holes or in areas of extreme gravitational distortion, could alter the behavior of electronic systems. This would explain the reactivation of long-dead sensors, the uncommanded antenna shift, and the strange pulses. Voyager 2 might not have malfunctioned, it might have been reprogrammed by the environment itself. The signal's final revelation was a set of numerical coordinates embedded in the data stream. To the astonishment of NASA and SETI astrophysicists, these coordinates pointed to an uncharted sector of the Kuiper Belt, a region of icy bodies beyond Neptune. The coordinates didn't merely indicate a location, they described a path, a trajectory through space. It was as if Voyager 2 was guiding humanity toward something. As telescopes, including the James Webb Space Telescope, JWST, turned toward the coordinates, anomalies began to surface. Stars in the region exhibited unusual flickering, inconsistent with known variable stars. Background radiation showed signs of gravitational distortion, hinting at an unseen mass or energy source. Some scientists proposed a collision between dark matter and baryonic matter, while others speculated about an artificial construct, a structure or device of unknown origin. Then came Voyager 2's final act. Its backup systems briefly activated, transmitting a short, encrypted burst before going silent. AI analysis of the signal revealed a spectrograph signature consistent with electromagnetic propulsion, a technology theorized for advanced interstellar spacecraft but never observed in nature. Hidden within the noise was a silhouette, a geometric shape too perfect to be natural. Could have been a derelict spacecraft, a space station, or something else entirely. Whatever it was not a product of human engineering. Voyager 2 fell silent after the final transmission, its power likely exhausted. Yet, the region it had pointed to continued to pulse. Faint signals, dismissed at first as quasars or gamma-ray bursts, arrived in sets of 3 seconds apart, every 72 hours. The precision and regularity of these pulses defied natural explanations, fueling speculation about a deliberate response. The scientific community turned its attention to Voyager 1, Voyager 2's twin, which had been silent for years. Reprocessing its old data with modern AI techniques, researchers discovered a chilling parallel. Decades earlier, Voyager 1 had detected a similar electromagnetic signature and magnetic anomaly, dismissed at the time as noise. The signatures from both probes were nearly identical, suggesting that the phenomenon had been active for much longer than anyone realized. The global scientific community mobilized. The JWST, along with other high-powered telescopes, focused on the Kuiper Belt coordinates. The data revealed distorted light patterns, anomalous gravitational lensing, and a massive, shadowy structure, blacker than space itself, with no emissions or movement. Its size and shape defied natural explanations. Was it a dormant beacon, an ancient vessel, or something beyond comprehension? The discovery sparked a wave of debate. Some argued it was a natural phenomenon, perhaps a rogue planet or a dark matter concentration. Others, emboldened by the signal's complexity, believed it was evidence of an extraterrestrial intelligence. The possibility that Voyager 2 had stumbled upon a cosmic artifact, an object designed to interact with probes like itself, ignited both excitement and fear. The Voyager 2 enigma challenges our understanding of the universe. If the signal was a message, who sent it and why now? If it was a warning, what danger lies in the Kuiper Belt? The idea of an informational field suggests that space itself could be a medium for communication, potentially connecting distant civilizations or even the universe's own consciousness. The transition zone hypothesis raises questions about the nature of reality, suggesting that certain regions of space operate under different physical laws. The coordinates and pulses hint at a purpose: a map, a beacon, or an invitation. The scientific community is now racing to develop new missions to investigate the Kuiper Belt anomaly. Proposed probes, equipped with advanced AI and propulsion systems, could take decades to reach the region, leaving humanity in a state of anticipation and uncertainty. The Voyager 2 signal has captured the public's imagination, sparking philosophical and existential debates. Religious leaders see divine implications, while skeptics demand more evidence. Governments and space agencies are under pressure to act, with calls for transparency and international collaboration. The discovery has united scientists, engineers, and theorists in a shared quest for answers, but it has also exposed humanity's vulnerability. If the signal is from an advanced civilization, are we prepared to face it? If it's a natural phenomenon, what does it reveal about the universe's hidden mechanisms? As of July 2025, the mystery remains unresolved. The JWST continues to collect data, while AI systems analyze the Voyager signals for new insights. Plans for a dedicated mission to the Kuiper Belt are underway, but the challenges are immense. The region is vast, remote, and poorly understood, and any mission would require unprecedented technological advancements. Voyager 2's legacy, once defined by its exploration of the outer planets, has taken on a new dimension. It has become a cosmic messenger, delivering a signal that could redefine humanity's place in the universe. Whether it was a glitch, a message, or a warning, one thing is clear: the void is no longer empty. Something is out there, and it knows we're here. The Voyager 2 signal is a turning point in human history. It challenges our assumptions about space, technology, and reality itself. The patterns, coordinates, and anomalies point to something extraordinary: an intelligence, a phenomenon, or a truth we have yet to grasp. As we await further discoveries, the world holds its breath, united by a single question: what did Voyager 2 find, and what does it mean for us?